Okay, this proof is actually kind of challenging because it's going to ask us to prove that AC is perpendicular to BD. So we want to try to prove this guy and this guy are perpendicular. What we have to do is first prove that their triangles are congruent, whether they ask us or not. Here they did, but this could have been crossed out completely and we'd still have to prove those triangles congruent. So let's get started and look at the givens. It says here BD bisects angle ABC. Well, where's angle ABC? It's right here. Okay, well, angle bisector divides an angle into two congruent parts. So we'll have this angle and this angle here. We'll call this 1 and 2 and mark them. They're going to be congruent because of that. Now, let's look at the other piece of information. AB is congruent to BC. So we got AB here congruent to BC. Okay, so we got two pairs of corresponding congruent parts. We need to find a third to prove those triangles are congruent. And if you look, they both share BD. So we could actually prove these triangles are congruent by, well, what kind of angles are these? Included or non-included? They're included. So these triangles will be congruent by side angle side congruence. So let's get started with this proof. I'm going to do a flow chart. So let's start with the given. BD bisects angle ABC. That's true because, well, it's given. That's how we started. And because of this, I can say, because I drew it in angles here, angle 1 is congruent to angle 2. Why? Well, an angle bisector divides an angle into two congruent parts. Okay. Now if you look at it, this happens to be the included angle, so I'm just going to mark it. Included angle, just to keep track. Let's start on the other part. The other piece of information is AB is congruent to BC. Now, well, this is the sides here and here. They correspond to each other. So it is exactly the way we need it. We just write given here and we will write side. Okay. Third piece of information is BD is congruent to itself, BD, and that's true because of the reflexive property of equality. Now, that is the third piece of information I need. It's a side. So because of these three, I know now that triangle ABD is congruent to triangle CBD. So this should say triangle here. Okay. And how do we know that this is true? We know this is true by these three pieces of information, which give us side angle side congruence. Now, here's something very important. I want to prove this right here, right? It's a little tricky, but what I'm going to do is first show that they're congruent, that this guy is congruent to this guy, okay? And that's true because, well, they correspond to each other, right? Angle ADB, this guy, corresponds to angle CDB, because in the triangles, well, D is at the end, so they do correspond. Let's state that. Angle ADB is congruent to angle CDB. Let me rewrite that a little neater. Okay, why is that true? Well, these triangles are now congruent, and we need to know that corresponding parts of congruent triangles are congruent. Now that's good. Okay, but how am I going to prove that these are actually right angles? Well, we have to do something that has nothing to do with the triangles. Let's look at this line right here and this angle. You see, these two angles at the end are congruent But what else? What other property they share? Don't they form a line? Well, yes they do. They're actually linear pairs. So that means ADB plus angle CDB equals 180 degrees. Okay, and the reason is linear pairs sum to 180 degrees. Okay, now interestingly, right, we could take this piece of information and this piece of information, do some substituting. We get angle ADB plus angle ADB is equal to 180 degrees. Why? Because of the substitution property. Okay. As we go through this, we could just simply simplify. Two angle ADBs are equal to 180 degrees. Okay, we'll just say simplify. And then what we do is we divide both sides by 2, right? And we get angle ADB is equal to 90 degrees. And this is true because of the division property of equality, which we don't really use very often now. So we know that ADB is a right angle. ADB. That's all we really need now. What do right angles do? We're going to go backwards, right? We can now say the final step. AC is congruent to BD. AC, excuse me, I said congruent, I should have said AC is perpendicular to BD. Why? Well, perpendicular lines form right angles, and it goes the other way. Right angles form perpendicular lines. And now the proof is done.